outside the solar system because gravity cannot bind it to the sun. It was moving too fast for that.
A sudden tremor in the stream of astronomical reports has echoed across observatories worldwide. Something colossal, a visitor of staggering proportions, has entered the solar system. Early measurements suggest that it is 100 times larger than the infamous interstellar traveler 3I/Atlas, a body that already captured the imagination of scientists and the public alike when it was first spotted. The revelation of this giant intruder has ignited both excitement and unease because its trajectory appears to bring it into interaction with none other than 3I/Atlas itself, setting the stage for one of the most extraordinary cosmic encounters ever witnessed by humanity. Before we start, smash the like and subscribe buttons for more updates. The initial data streamed in from an array of wide-field telescopes scanning the outer regions of the solar system. What began as faint anomalies in starfield brightness quickly transformed into undeniable proof of a body whose dimensions dwarf nearly all known comets and asteroids. As astronomers refined their readings, the enormity of the discovery became clear. This object is not simply another visitor from deep space. It is a leviathan, a structure whose diameter may stretch thousands of kilometers, making it nearly planetary in scale. That such a body has gone unnoticed until now speaks volumes about the vastness of interstellar darkness and the limitations of even our most advanced instruments. Yet here it is, slipping into our neighborhood, its presence impossible to ignore. The notion that this giant is targeting 3I/Atlas adds another layer of intrigue. Celestial mechanics is an elegant dance of mass, momentum, and gravity, and within that dance, collisions or near encounters are rare but not impossible. Current trajectory models suggest a convergence path that will bring the newcomer into startling proximity with 3I/Atlas, raising possibilities ranging from gravitational capture to catastrophic collision. Astronomers are scrambling to refine orbital models, knowing that even the smallest error margins could drastically alter predictions about what is to come. The thought of two interstellar bodies, one already enigmatic and the other far more massive, approaching interaction is a scenario without precedent in recorded history. The scale of the object itself demands rethinking of categories. While 3I/Atlas and its predecessors like Oumuamua were classified within the cometary or asteroidal families of interstellar visitors, this new intruder may demand its own designation. Its mass suggests it could carry the equivalent of entire planetary crusts in its composition. If composed of ice, it might contain enough water to replenish the oceans of Earth many times over. If rocky, it could rival the mass of small moons. Its gravitational pull alone is significant enough that it may temporarily alter the orbits of minor bodies in the outer solar system, disturbing ancient clouds of comets and debris in ways that could echo for centuries. In that sense, the object is not merely passing through, it is reshaping the neighborhood in real time. Attention now turns to the nature of the interaction between the object and 3I/Atlas. The latter, though modest in size by planetary standards, is itself an interstellar traveler whose path through the solar system already drew great scientific interest. To have another, far more massive body appear on a trajectory intersecting its course is akin to watching two titans cross paths in the night. Will the larger body capture 3I/Atlas into orbit, creating a temporary interstellar binary system within our own skies? Could their gravitational interplay trigger outgassing, fragmentation, or other volatile reactions that would release unprecedented streams of matter into the solar system? Or might we witness the almost unthinkable, a direct collision that would create a luminous burst of energy visible across vast distances, a spectacle that could rival the brightness of planets or even stars? The sheer possibility of such events is galvanizing every branch of astronomy. Observatories are realigning, satellites are tasked with near-constant monitoring, and computational clusters are whirring at full capacity, simulating every conceivable outcome. The implications stretch far beyond academic curiosity. Humanity has long viewed interstellar objects as rare messengers, fragments of alien systems offering whispers of distant places. Now, one of those messengers is bringing with it a companion so large that it may forever change our understanding of what drifts between the stars. The data gathered from its surface composition, reflective properties, and emissions could provide an unparalleled sample of material forged in another stellar nursery, preserved for eons in the cold of interstellar space, now finally within reach. Beyond the scientific implications lies the psychological dimension. News of this immense arrival has captured public imagination in ways even prior interstellar visitors did not. The human mind grapples with scale, and the thought of something 100 times larger than what was already extraordinary inspires awe tinged with fear. In classrooms, discussions shift to the fragility of planetary systems and the precariousness of cosmic order. In research institutions, debates unfold about the potential classification of this object. Is it a rogue planetesimal, a fragment of a shattered world, or something entirely new? A category of interstellar wanderer that challenges established taxonomies? The very language of astronomy strains to keep pace with the reality of what has entered our skies. Speculation also blooms about the object's origin. A body of such magnitude cannot have formed casually. It must be the relic of cataclysmic processes in another star system. Perhaps it is the core of a failed planet that never accreted fully around its star. Perhaps it is debris ejected during the violent death throes of a supernova, blasted free into interstellar dark. Each possibility ties the story of this object not only to our solar system, but to events across cosmic time and space, linking our own planetary neighborhood to distant stellar dramas. In studying its properties, humanity may indirectly study the histories of stars long extinguished, their remnants carried into our presence by the silent currents of the galaxy. The encounter with 3I/Atlas provides a natural laboratory for celestial dynamics. The gravitational resonance between the two bodies could unveil secrets of how massive wanderers interact with smaller companions. It may model on a smaller scale the processes by which moons are captured, or by which rogue planets destabilize existing systems. Every observation will feed back into theories of planetary system evolution, migration, and destruction. For planetary defense researchers, this is also a moment of sober reflection. Although the massive object itself is not on a path to Earth, its capacity to scatter smaller debris inward reminds us of the delicate balance that shields our planet from the ceaseless hazards of space. A single gravitational nudge from such a titan could redirect icy bodies toward the inner system, seeding meteor showers, or, in worst-case scenarios, dangerous impacts. For engineers and mission planners, the discovery prompts questions of feasibility. Could a probe be redirected in time to intercept and study the giant as it passes through? Missions designed for smaller bodies might not withstand the sheer gravitational and radiative environment of such a colossus, yet the potential rewards are staggering. A close encounter with this visitor would mean direct sampling of interstellar matter on a scale never before imagined. Even a flyby could reveal surface chemistry, magnetic field properties, and clues about its structural integrity. The window of opportunity is narrow, but history shows that when the cosmos presents such a moment, humanity rises to the challenge. Meanwhile, theoretical physicists explore more exotic implications. The object's mass and speed raise questions about whether it could carry with it complex magnetic environments, or whether its interaction with the solar wind could create dazzling phenomena like interstellar auroras visible across planetary skies. The potential collision or capture of 3I/Atlas within its sphere of influence may provide a natural experiment in energy transfer and fragmentation. If 3I/Atlas is shattered, its debris could illuminate not just the structure of the smaller body, but the mechanics of high-energy impacts in the cold vacuum of space, a process often theorized but rarely observed at such scale. In contemplating the scale of this event, it is worth remembering the humbling truth it reveals about our place in the galaxy. For centuries, humanity assumed that the solar system was a relatively isolated domain, its borders defined by the Oort cloud and the heliopause. Yet time and again, interstellar visitors have reminded us that the galaxy is far from compartmentalized. Objects wander, systems exchange material, and the line between ours and theirs is porous. The arrival of this 100x larger object shatters any illusion of separation. It underscores that our solar system is but a waypoint in the grand currents of the Milky Way, and that we are far from alone in the stream of cosmic travelers. As the object continues its approach, attention will remain fixed on its interaction with 3I/Atlas. This convergence is not merely another line in the catalog of astronomical events. It is a front-row seat to a cosmic drama of unimaginable scale. For the first time, humanity may witness the choreography of two interstellar wanderers meeting within our solar system, their fates entwined for a fleeting but unforgettable moment. Whether their interaction results in capture, collision, or a dramatic near miss, the implications will reverberate through astronomy, astrophysics, planetary science, and even philosophy. It will remind us that the universe is far larger and stranger than we ever dared to dream, and that at any moment its vast stage may deliver a spectacle to humble and inspire. And so, telescopes turn, algorithms refine, and humanity waits, gazing into the darkness where this Leviathan advances. A century from now, scholars may look back on this moment as a turning point, when our understanding of interstellar dynamics leapt forward, when our appreciation for cosmic scale deepened, and when we glimpsed the raw power and mystery of the galaxy flowing through our solar system. The event unfolding is not one of aftermath, but of immediacy, a living chapter written in real time across the vault of the heavens. We stand not as mere spectators, but as chroniclers of an encounter that binds our world to the wandering giants of the stars. The discovery of the gargantuan object now moving through the solar system is more than a headline. It is an unfolding event reshaping our relationship with the cosmos. Astronomers knew that interstellar visitors would continue to arrive after Oumuamua and 3I/Atlas. Yet the magnitude of this newcomer defies every prior assumption. To find something 100 times larger than 3I/Atlas on a converging trajectory is not only unprecedented, it is transformative. The scale demands an entirely new mode of thinking, and the implications spread across science, technology, culture, and even the deepest recesses of human imagination. Every time an interstellar body enters the solar system, it carries a story of distance and time written into its structure. With Oumuamua, the story was one of strange geometry and reflective properties, prompting speculation about its artificiality. With 3I/Atlas, the story became one of fragility, as the body fragmented under solar stresses. Now, with an object far larger and more durable, the narrative shifts toward resilience and endurance. Its survival through countless light years of interstellar radiation and collisions suggests a body forged in extreme conditions. By studying it, humanity gains a direct sample of galactic history preserved outside the processes that shaped our own planetary system. The massiveness of the object means it is not merely a fragment, it is a survivor of something vast, perhaps once bound to a star before being ejected into the abyss. This distinction elevates its importance. A small body can tell us about dust, ice, and fragile minerals. A massive one tells us about tectonics, differentiation, and planetary architecture. Its composition could reveal the building blocks of alien worlds, possibly even materials unfamiliar in our own solar system. It represents a mirror held up to our planetary science, forcing us to ask whether our assumptions about planet formation hold true across the galaxy, or whether we are seeing an entirely new blueprint of creation. The trajectory bringing this object into alignment with 3I/Atlas creates one of the most remarkable gravitational encounters ever anticipated. Gravity, though predictable in principle, can lead to outcomes of startling complexity when two bodies interact at close quarters. Depending on their relative velocities, densities, and approach angles, the encounter could yield anything from deflection to capture. If capture occurs, the two might orbit one another, forming a temporary interstellar binary drifting through the solar system. Such a sight would not only captivate the human eye, but also serve as a natural model of how binary asteroids and planets might form under chaotic conditions. On the other hand, a collision would unleash energy on a scale rarely observed. The impact of two interstellar bodies, one of them immense, would produce a debris field glowing with heat and light, scattering materials across millions of kilometers. That debris could itself become a point of study, a smorgasbord of alien compounds made suddenly available for sampling. Every outcome, whether collision, capture, or near miss, offers science something invaluable. The cosmos rarely provides front-row access to such spectacles, yet this one is unfolding within observational range of our telescopes and probes. One of the most profound aspects of this discovery lies in its implications for how material circulates through the galaxy. If an object this large has been wandering between stars for millennia or even eons, it suggests that the ejection of massive bodies is not as rare as once thought. Entire populations of rogue planetary fragments may be threading silently through the galaxy, invisible until they pass near a star system. If true, the Milky Way is less a collection of isolated solar systems and more a dynamic network where matter is exchanged freely. This view reframes how we think about habitability and the origins of life. Rogue bodies can carry with them not only rocks and ices, but also organic molecules, frozen in time. If they pass through multiple systems, they may scatter such molecules into planetary nurseries, seeding them with precursors to biology. The newly arrived giant could therefore be more than a geological oddity. It could be a courier of potential life, a galactic messenger carrying chemistry from worlds unknown. For astrobiology, the implications are staggering. To sample its surface may be to reach across the gulfs of interstellar space and touch the heritage of countless stars. The arrival of a body of this size does not remain confined to the walls of observatories. News spreads, and with it, humanity's collective imagination ignites. Writers, philosophers, and thinkers ponder what it means for our place in the universe. The sheer size of the object raises questions that border on the existential. Are we truly prepared for the scale of the cosmos? How many other giants wander the galaxy unseen? For some, the event is humbling, a reminder of our fragility in a universe indifferent to scale. For others, it is invigorating, proof that the universe continues to offer mysteries capable of surprising even the most advanced scientific minds. Entire cultural movements may emerge around this leviathan, much as comets once inspired myth and prophecy. Artworks, literature, and even political discourse may draw from the symbolism of a cosmic giant intruding into our system, echoing the human need to weave meaning into the incomprehensible vastness of space. The opportunity to study this object pushes technology to its limits. No current mission was designed with such a target in mind. Probes like New Horizons or missions in planning stages for small comets and asteroids lack the capacity to engage with a body of this magnitude moving at interstellar speeds. The challenge inspires a technological sprint. Can humanity redirect resources to launch a probe, even a minimalist one, fast enough to intercept the object before it departs? Such an endeavor would force innovation in propulsion, navigation, and data transmission. Even if direct interception proves impossible, remote sensing from existing satellites can be maximized. Infrared, ultraviolet, and radar studies may reveal layers of detail, each requiring recalibration of instruments and methods. The object thus becomes not just a subject of study, but a catalyst for advancing the frontier of space technology, driving progress that may later serve humanity in exploring other frontiers. At its core, the event underscores the interconnectedness of the galaxy. For too long, humanity has imagined the solar system as a self-contained bubble, secure within its orbital clockwork. Yet interstellar visitors show that no such bubble exists. Material flows across the galaxy in a ceaseless tide, reminding us that we are participants in a larger whole. The giant object is proof of cosmic exchange at the highest scale, a testament that no system is isolated. This realization reshapes the way we conceive of cosmic security and exploration. It suggests that the future of astronomy must not only focus inward, cataloging our planets and moons, but outward, developing strategies to detect and study the wanderers that cross our paths. The arrival of a body 100 times larger than known interstellar visitors is both warning and invitation. It warns us that surprises of colossal scale are possible, and it invites us to broaden our horizons, to see ourselves as part of a galactic network rather than a solitary island. Amidst the grandeur of the giant, it is easy to overlook the significance of 3I/Atlas, the smaller companion in this unfolding drama. Yet its role is critical. Without 3I/Atlas, the newcomer's trajectory might have been of interest but not urgency. The convergence of the two gives the event its immediacy and drama. 3I/Atlas, already a rare interstellar visitor, now finds itself part of a cosmic encounter that magnifies its importance beyond measure. The way the smaller body reacts to the presence of the larger one will provide insights into structural integrity, gravitational stress, and fragmentation processes. If 3I/Atlas survives unscathed, it tells us something about the resilience of interstellar matter. If it fractures or alters course, it offers a window into vulnerabilities and dynamics that shape the lifespans of such bodies. In a sense, 3I/Atlas becomes the lens through which we study the Leviathan, its fate interwoven with the drama unfolding across millions of kilometers of space. The timing of this event could not be more fortuitous. Humanity stands at a threshold, with telescopes like the James Webb Space Telescope and upcoming ground-based observatories designed for unprecedented precision. We have for the first time the instruments capable of parsing subtle details of interstellar bodies. The convergence of this technological readiness with the arrival of the giant object feels almost theatrical, as if the universe itself were presenting us with a stage performance of unmatched scale. For scientists, this is not coincidence, but opportunity. The alignment of cosmic event and human capability means data will be gathered at levels once unimaginable. Every wavelength of light, every particle of dust, every nuance of trajectory will be recorded and analyzed. The object's presence becomes a living laboratory, a transient classroom in which the universe delivers its lessons directly. No matter how refined our models, the truth is that this event carries with it the weight of unpredictability. Nature has a way of defying human expectation, and when dealing with interstellar masses on this scale, the potential for surprise is immense. Will the object reveal features that make it more akin to a planet than a comet? Will 3I/Atlas be drawn into an orbit we can study for years? Could electromagnetic interactions between the two create phenomena never before observed? Astronomers know that they cannot prepare for every possibility, but they can prepare to observe. Networks of observatories are coordinating, data pipelines are being streamlined, and international collaborations are being formed in real time. The spirit of scientific unity rises to meet the event, reminding us that some discoveries transcend borders and politics. In the face of a cosmic giant, humanity becomes one community of observers united in curiosity and wonder. Long after the object has passed, the data it leaves behind will continue to shape scientific inquiry for decades, perhaps centuries. But even in the present, its significance is not in its aftermath, but in the moment of its arrival. To witness such an event while it unfolds is to stand at the intersection of history and mystery. Generations yet to come will look back on this as a defining chapter when humanity confronted not destruction or aftermath, but the pure immediacy of cosmic scale. The giant's presence, converging with 3I/Atlas, is not an epilogue. It is the central act of an ongoing drama. As its massive bulk cuts across the darkness, as telescopes lock onto its path, as models strain to capture its complexity, we find ourselves drawn into a story written across the fabric of the galaxy. The encounter is here, it is now, and it is vast. The immensity of the newly arrived body has begun to force scientists and thinkers alike into questions that stretch beyond physics. When an object 100 times larger than 3I/Atlas drifts into the solar system, converging on that smaller interstellar wanderer, it does not merely demand observation, it demands interpretation. What is its deeper significance? Why now, when our tools and technologies are poised to study it? And what can it teach us not only about the universe, but about ourselves? These questions cascade into layers of speculation, theory, and imagination, each one deepening the mystery while expanding the horizon of what this event could mean. One of the most compelling aspects of this colossal body is its role as evidence for galactic processes on scales previously unseen. For centuries, astronomy has been dominated by the study of stars and planets bound to stellar systems. Interstellar space, by contrast, was considered empty, an expanse traversed occasionally by dust or faint gas clouds. Yet the appearance of a body this massive reveals that interstellar space is far richer and more dynamic than once assumed. This is not just a solitary rogue, it is a testament to the fact that stars and their planetary systems are constantly shedding material into the galactic medium. The object may have been expelled by a gravitational interaction with a giant planet, or it may have been hurled outward by a catastrophic stellar event. Its sheer survival, intact across what could be billions of years, suggests that the galaxy is seeded with a hidden population of such travelers, unseen until they cross the threshold of a system like our own. This paints a picture of the Milky Way not as a static collection of neatly bound systems, but as a living, exchanging organism. Stars give birth to planets, planets eject fragments, fragments wander and collide, and in this way material and information circulate endlessly. The giant's arrival is a reminder that our own solar system participates in this grand exchange, a node in a much larger network of galactic dynamics. To study the body is to practice a new form of science, interstellar archeology. Just as archaeologists unearth fossils and pottery to reconstruct lost civilizations, astronomers now have before them a fossilized record of another star system, preserved in the bulk of this immense wanderer. Every chemical bond, every isotope ratio, every mineral layer locked within it is a clue to the environment in which it formed. If its surface shows evidence of tectonic activity, it could mean it was once part of a larger, differentiated world with a molten interior. If it contains exotic minerals not found in the solar system, it could hint at elemental abundances unique to its parent star. The detection of complex organics would be even more momentous, offering direct proof that the chemistry of life is widespread and not confined to Earth's vicinity. Each possibility pushes science forward, not in theory alone, but in concrete evidence pulled from the stars. The human imagination strains under the weight of scale. To comprehend a body 100 times larger than 3I/Atlas is to attempt to place a mountain beside a pebble. Visualizations already circulate, depicting the Leviathan against familiar planetary backdrops, its size dwarfing known comets, asteroids, even some moons. For the public, these images ignite a fascination that is as emotional as it is intellectual. This spectacle becomes a unifying cultural event. Families gather to watch news segments. Artists produce works inspired by its enormity, and children dream of being the ones to study such bodies in the future. The awe it inspires transcends borders and politics, creating a rare moment where humanity can look upward together, reminded that we are inhabitants of a tiny world in a vast interconnected cosmos. Though its trajectory poses no immediate threat to Earth, the gravitational influence of a body so massive cannot be dismissed. In passing through the outer solar system, it has the potential to disturb smaller bodies in the Kuiper Belt, or even the distant Oort cloud. These regions are home to countless icy objects, some of which can be deflected inward toward the planets. Even a slight perturbation could send a wave of comets cascading inward, a ripple effect that might unfold over centuries. Such a process would not be immediately dangerous, but would underscore the fragility of our planetary defenses. Earth's history is marked by impacts, some catastrophic, and the arrival of this giant is a stark reminder that the sky is not empty, but alive with potential hazards. Planetary defense agencies monitor the situation with quiet vigilance, knowing that even indirect effects could shape the environment of the inner solar system long after the visitor departs. The mass of the object also makes it a candidate for something rarely witnessed on such a small scale: gravitational lensing. As it moves against the starry background, its gravity may bend light from distant stars, creating distortions detectable with precision instruments. Observing such lensing could allow astronomers to measure its mass with far greater accuracy than simple trajectory calculations allow. Even more intriguingly, the lensing effect could reveal faint background objects otherwise invisible, effectively turning this interstellar giant into a natural telescope. The phenomenon would be fleeting but invaluable, offering a chance to glimpse stars or galaxies hidden in the cosmic distance. In this sense, the body is not only an object of study but a tool of study, its presence enabling discoveries beyond itself. When confronted with a body of such magnitude, humanity is inevitably drawn to philosophical reflection. What does it mean to live in a universe where titans drift unseen until they arrive at our doorstep? For centuries, humanity's myths and religions have spoken of cosmic giants, gods, and beings of immense power. Now, in the age of science, a literal giant has come. Not a creature of legend, but a physical body of stone and ice, yet no less awe-inspiring. This convergence of myth and reality sparks dialogue across disciplines. Philosophers see in it a reminder of our smallness, a challenge to anthropocentrism. Theologians interpret it as a sign of the universe's boundless creativity. Futurists consider it a metaphor for the challenges that lie ahead, vast and unexpected. In every case, the giant functions as a mirror, reflecting back humanity's attempts to find meaning in a cosmos that is at once indifferent and magnificent. The scale of the discovery has already catalyzed unprecedented international cooperation. Space agencies, universities, and private observatories are pooling data, sharing telescope time, and coordinating missions. Rivalries that once defined scientific competition are set aside, at least temporarily, in recognition of the uniqueness of the moment. This spirit of collaboration extends to the public as well. Amateur astronomers contribute valuable observations, their backyard telescopes adding to the global dataset. Citizen science platforms surge with participants eager to play a role in documenting the giant's progress. The object becomes a unifying project, an enterprise that shows how science can function not only as a pursuit of knowledge, but as a bridge between cultures and generations. Describing the object also challenges the boundaries of language. Terms like asteroid, comet, or planet fall short of capturing its unique scale and origin. Scientists debate what classification to use, with some proposing new terminology altogether. This struggle reveals the limitations of human categories when faced with something truly novel. Language is not a trivial concern. The words chosen to describe the giant will shape how the public understands it, how future generations remember it, and how it is placed in the taxonomy of cosmic phenomena. Naming committees deliberate carefully, aware that whatever title is chosen will echo through history as humanity's label for one of the greatest visitors ever to grace our skies. Speculation continues to grow about what secrets may lie hidden within the body. Could it contain internal caverns, preserved by low temperatures and shielded from cosmic radiation? Could it harbor exotic ices such as frozen ammonia or methane hydrates in quantities unknown in our system? Each hypothesis suggests that the giant is more than a surface spectacle. It is a layered mystery, with each stratum holding potential surprises. Probes and telescopes may never fully unravel its secrets, but even fragments of data could revolutionize fields of study. The discovery of isotopes with unusual ratios could point to nucleosynthesis in long-dead stars. Magnetic anomalies could hint at cores rich in metals. Organic compounds could reshape theories of life's cosmic distribution. The object is both a question and an answer. Its arrival rewriting textbooks even before it has been fully studied. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on a 100x bigger object entering our solar system? We want to hear from you. Thank you for watching, and see you next time.